of del of t. So you see the graph. So from the graph, what is del of t? So the del of t signal is having value only at a time t equal to 0. At a time t equal to 0, so here we are putting one arrow. So what is the meaning of this arrow? Means the amplitude of this impulse signal is infinite. Okay, so it's not a definite amplitude. It's not a 1, it's not a 2. The amplitude of the impulse signal is going to infinity. Okay, that's the meaning. For the remaining time t, there is no signal, there is no amplitude in the unit impulse signal. So this is a continuous time unit impulse signal. Okay, you see what is unit impulse? The unit impulse is having infinite amplitude at a time t equal to 0. For the remaining amplitude, the signal is having no amplitude. It is the definition of unit impulse. Okay. And what is the another one property of this unit impulse signal? Means the area under this del of t function is always 1. Okay. So the area under the impulse function is always 1. That's why this impulse signal is called as unit impulse signal. Why the name is said to be unit? Means the area under the impulse function, it is 1. Okay. So what is the formula in order to find area under any function? We have to integrate the particular function with respect to the limit minus infinity to infinity. So by integration of minus infinity to infinity del of t dt, whose answer is 1. Okay. So the area under this unit impulse signal is 1. Okay. It's an important property of this unit impulse function. Okay. And this del of t, it can be described as, so del of t equal to 1 for time t equal to 0. And for time t not equal to 0, the signal is having amplitude 0. So it is a mathematical representation of this unit impulse signal. Okay, this is the continuous unit impulse signal. And what are the importance of this delta function? Okay, this impulse function is otherwise called as delta function. Okay, so what are the importance of this delta function? Means this impulse signal, it play a very important role in the analysis of communication system. Okay, communication system. So in that communication system, in order to analyze the communication system, always we are deriving unit impulse response. Okay. So from the unit impulse response, we can say the nature of the particular system. Okay, that's the importance of that impulse function. Okay, so next one, we are going to see the discrete time unit impulse signal. Okay, so that always the discrete time signal is called as that is a signal or we may call it as a sequence. Okay, we may call it as a sequence. So what is discrete time unit impulse? Means the discrete time unit impulse is denoted by same del but del of n. Okay, continuous means del of t, discrete means del of n. So how to describe del of n? Del of n equal to 1 when n equal to 0 and 0 when n not equal to 0. So this is the graphical representation of del of n. Over here the del of n is equal to, you see the del of n graph, the del of n is having the amplitude 1 whenever the n is equal to 0. For the remaining sample value, the signal is having not at all having any amplitude. Okay, so it is the discrete time sample sequence. So but what is the difference between del of t and del of n? Del of t is having infinite amplitude at time t equal to 0. Okay, but del of n is having amplitude 1 at n equal to 0. So that is the difference between these two impulse signals. Okay, so the next one, the third standard signal, unit ramp signal. So ramp, so that's why the ramp signal, it is denoted as R of t. Okay, so in ramp signal itself there are two things. One is continuous time ramp, discrete time ramp. So ramp, you know, okay, so the ramp signal, it is nothing but a linearly growing signal. Okay, so linearly growing signal means, you see this is the graph of the ramp signal. Okay, before time t equal to 0, the signal is having 0 amplitude. At time t equal to 0 and after time t equal to 0, the signal is the amplitude of the particular signal is linearly increasing. Okay, but linearly increasing means if whenever the time t equal to 1 means the signal is having amplitude 1. The time t equal to 10 means the signal is having amplitude 10. So this type of signal is called as a ramp signal. Okay, the shape is like a ramp. That's why the name is called as a ramp signal. Okay, so but how to define this ramp signal? The R of t equal to t. Correct? R of t equal to t for t greater than or equal to 0. For t less than 0, the signal is having 0 amplitude. Okay, t. So for example, t equal to 0 means r of t 0. T equal to 1 means 1. T equal to 2 means 2, etc. Okay, so that's why what is the mathematical expression for r of t in terms of u of t means the r of t it can be related as t into u of t. What is mean by u of t? The unit step function, it is having amplitude 1 for time t greater than or equal to 0. Similarly, the r of t signal is also having amplitude t for t greater than or equal to 0. That's why the r of t it can be expressed as t into u of t. Okay, this is the continuous ramp. So next one, this is a discrete time unit ramp signal. Okay, this is the 2018 question. Okay, or that is a mathematical, write down the mathematical and graphical representation of discrete time unit signal. This is the 2-mark question, university question, 2018 question. Okay, about how to describe a discrete ramp. You see, what is the mathematical expression for unit ramp? A unit ramp, it can be described as R of n. Okay, since it is a discrete, so R of n. So R of n equal to, instead of t, here we have to put n. So R of n equal to n for n is greater than or equal to 0. 0 for n is less than 0. Okay, and otherwise this R of n can be described as R of n equal to n into u of n. If it is a continuous ramp, R of t equal to t into u of t. So in the place of t, if you are substituting n means that is said to be the ramp signal. Okay. So this is the graphical representation of ramp. You see, this is a discrete time signal. What is discrete? The signal is having amplitude in particular instant of time. That is, whenever n equal to 0, the amplitude is 0. Whenever the n equal to 1, the signal is having amplitude 1. When n equal to 2, the signal is having amplitude 2. When n equal to 3, amplitude is 3. 4, 4. Okay, so this is said to be the discrete time unit ramp signal. Okay, so this is the third type of signal. And so now we discussed the 3 standard signals: unit step, unit impulse, and unit ramp. Okay, so there is a relationship between this unit impulse, unit ramp, and unit step signal. Okay, in the continuous time. Okay, this relation, it's a very important question. So it's a repeated question. Okay, so this question is asked in 2018 and 2015 as a 2-mark, or sometime we have to derive this relation. It is a 8-mark question also. Okay, so for 2-mark, how to write means the relationship between this unit step, unit impulse, and unit ramp signal, it is represented as, you see, this is del of t is a unit impulse, u of t is a unit step, R of t is a unit ramp. Okay, so if you are integrating the unit impulse, we will get unit step. Okay, if you are integrating this unit step, we will get unit ramp signal. Okay, this is a one relation. Okay, and in reverse, okay, so in reverse, if you are different